All right, everyone, we're going to get started. I have the pleasure of introducing John Page, our speaker for today. John is a distinguished engineer here at MongoDB. He's been at MongoDB for 9 years and has taught MongoDB's new hire technical training, which I had to go through, for a couple of years. This talk is a session from that new hire technical training. You should all have a paper and pen on hand, and if you need one, let me know. Also, be sure to rate this session at the end in the app provided for the conference. Thank you, and welcome, John. Please give a round of applause for John.
Thank you, everybody. Okay, so as Elder said, this is basically this is what we do with people that come and work for MongoDB. This is part of our bootcamp training. And this is, again, all part of what we do and what I do whenever I'm giving training. I want you to make sure you've got a buddy. Nobody's sitting on your own because you're going to work in pairs on this exercise. It's also going to be lots of Q&A. There's going to be lots of questions that I ask you and you have to answer. Okay, so if you think you're just going to sit there and hear me talk about stuff, well, not so much for this one. Okay, all good. Does everybody have a piece of paper, a pen, and a buddy? Hands up if you don't have any of those things. Good. There are some bits of paper and pens around. Okay, could you pass me a piece of paper up? Okay, so the first thing is a little exercise to make sure you can follow instructions. Okay, so you're going to have a piece of paper like this, and I need you to make sure there are 12 boxes on it. Now, the easiest way to do this, I should have not have had a handheld mic for this, hold on, is you fold it in half, and half again, and then into 3, and you'll figure this out. You end up with 12 little boxes on your piece of paper. Doesn't have to be tidy, as long as you've got 12 boxes. Like so. Okay, you did not know you were getting an origami lesson today. Here is how to not do origami. Okay, now assuming you managed that part, the next thing I wish is I could actually read my slides. So, okay, this is going to be fun. Right, so I want you to imagine that you are going to write a new driver for MongoDB. You have a programming language. It's a normal programming language, but for some reason there isn't a driver for it. So you are going to write one. And you have a team of people to help you with this. You're not doing it all on your own. But what you are going to have to do is kind of apportion the work to those people. So you're going to have to work out what are the different things the teams are going to have to do. And the idea is you're going to write down in each of the boxes on your piece of paper one of the sub pieces of work involved in writing a driver. Now, I'm sure you're going to write some specifications for them, and everybody's going to know what they do, and each of your teams is going to work on one of those things to the specs, and it's all going to work together. So what you need to do is figure out, what are the things that go into a MongoDB driver? Now, just a very quick show of hands. Does anybody not know what a MongoDB driver is? Oh, okay. This is why we have the data API. So MongoDB driver is a library which links to your programming language and which provides all the functions you need in order to interact in an idiomatic way with MongoDB. So, for instance, it does. Yeah, I'm probably not going to tell you this because your exercise is to figure it out. Hopefully those people are sitting with somebody who does know what a driver is, and we'll get this. So I'm going to give you 2 things to get started. And I really do have a problem here because I want to be able to see my slide and I can't. Can the AV people help me with this? I don't even have a cursor. Oh, that's because it's over there, right? I can't see the notes. Okay, so 2 examples of what you might get in a driver. We can just make that bigger. So for example, you need a piece of code which can parse a MongoDB URI. So when you connect to MongoDB, you give it a connection string, MongoDB plus SRV, some hosts, a bunch of options, and all the rest of it. So you're going to have to write a piece of code that takes one of those and basically checks that it's legit and sets a bunch of options. Show of hands if you understand what I mean by that. Okay, so that's a piece of work you could easily hive off to a team. It's like, look, here's the spec for a URI. Go and write a class that I give it a string, and then I can say, uses SSL and it returns true or false, and then that'll be what we can do. I need this one to be big because I can't see that screen. Ah, cool. I just couldn't see, it's black on black. I couldn't see the cursor. Thank you very much for that. Okay, you also need a piece of code that can create MongoDB object IDs. So MongoDB has that nice GUID data type, the object ID. If you forget to add _ID to your records, we add one in for you. It's actually like a date and then a random part and then a piece that increments every second. So you're going to need a piece of code that kind of represents that object ID type so that we can add them to records for you if you need. Again, everybody understand that? So that's the kind of level of things we're looking at. And I have probably about 24 things here that you would have to build, individual bits and pieces to build a driver. What we're going to do is we're going to play driver bingo. So you're going to write down your 12 things that you think we need in a driver. I'm going to give you 4 or 5 minutes to do that. Talk amongst yourselves, and then I'm going to go through the list and you're going to tick them off when you get them, and if anybody gets a full card, shout bingo and I will probably go and try and find you some swag. Okay, everybody understand how this works? Right, you have approximately 5 minutes to work in pairs and come up with 12 modules you'd need to write to build your own driver. No pressure, 2 minutes left. One minute, get these things scribbled down. Don't debate too long, get those boxes filled in. 5, 4, 3, 2, 1. Okay, so if this were a real exam, it would be pens down now and everybody going, but I didn't get it finished. Did anybody get 12 written down? 10? 10, 11. That's a great word in Scottish. 11. It's like voice recognition fails miserably. Okay, right. So what I'm going to do is I'm going to go through some of the things that are in a driver. If you have something that you think is what you wrote down on your piece of paper, I'm going to trust you here. I want you to tick it off, and we're going to see how well you do. So the first thing, you're going to need something that does SRV and text record resolution. Remember I said you got that connection string. So sometimes we fire that connection string off to DNS and we get back an SRV or a text record. You know, the MongoDB plus SRV, those are great because they contain all your host names and all your settings for you. But you're going to have some way of parsing and understanding them. You're going to need something that converts BSON to objects and objects back to BSON. And if you're unfortunate enough to be using a language which isn't object-orientated, you're probably going to have some form of BSON object as well. I don't know if anybody's worked with the C driver, but you know, in this object-oriented world, that's a most entertaining thing to deal with BSON. You're going to need to do connection pooling and monitoring. Who got that one? Who got connection pooling? Oh, those are the people that have struggled with Lambda then. Okay, so yeah, you're going to have connection pooling. Because you want to reuse connections to the server. You want to get connected and you want to reuse those as much as possible. You're going to have to deal with authentication. The thing about authentication is it's not just a case of I send the username and password to the database. You know, I need to be able to do SCRAM. I need to have the database send me a challenge that I solve. I need to integrate with Kerberos. I might even have to integrate with AWS IAM. So yeah, you're going to have somebody deal with the whole authentication thing, and that's a whole heap of code. The idea behind this, by the way, is just to give you some feel for just how much work is involved in writing a driver that works. There's a lot. That's why we have, as Mark Porter said in his keynotes, we've got 12 different teams, all of whom work on their own driver. Network compression. MongoDB has network compression, so you're going to have somebody that builds a module that compresses the stuff. I'm getting some nods, so at least everybody was on the right track here. You know, I might get through this list far too quick, in which case you get to call out the stuff that I haven't. Client-side field level encryption. Okay, who knows the new name for client-side field level encryption? Searchable encryption, yeah, or absolute black magic, as we like to refer to it. You know, I think it was Asimov. No, it was Arthur C. Clarke that said, technology sufficiently advanced is indistinguishable from magic. I promise you that the new searchable encryption definitely falls into that category. Cursor management. So you send a search operation to the server, it says, yay, here's some results, and here's a cursor. So if you want to get some more results, but you've got to hang on to that. You've got to make that whole concept of a cursor object. Wire protocol and commands. So this is a kind of low-level thing, but you need to actually understand what bits and bytes MongoDB wants to send over the wire. And also commands. The idea with MongoDB is we didn't want to make a wire protocol, a method of pushing stuff from the client to the server that was absolutely rigid. Because what if we added a new capability in the server? We didn't want everybody to have to reach out and write a new driver or upgrade to a new driver. So we have this idea of commands. So we send over the wire, here's an operation I want you to do. It's called create index, and here are some parameters. So when we add a new command, all the old drivers can support it. They might not have a nice, friendly way of doing it, but they can still send the required operations. You need a high-level CRUD API. Commands are great, but people really do like to be able to just type find or aggregate or update one. So you're going to have to build that high-level API. And of course, because we like all the drivers to be similar, it would be nice if your high-level CRUD API matched up with everybody else's high-level CRUD API. How are people doing? Anybody got 3 or 4 of these yet? Oh, good. A good audience today. Anybody have GridFS? There's a rumble there. No, so GridFS is built into the driver. GridFS is how you deal with large files in MongoDB. So you can say, hey, store this 1 GB file in MongoDB. And MongoDB, the driver, will actually break it up into small chunks and store those in individual records and all the metadata for it. So there's that 15 megabyte limit to how large a document you can put in MongoDB. But GridFS gets around that for you by breaking it up and storing it and retrieving it and giving you like a file style API. Nobody had it. Had anybody heard of GridFS? Well, that's a small number of hands. Okay. Oh, I see our Director of Developer Relations has heard of GridFS. That's quite good. That's because you've been around a long time. Support for change streams. You know, we're going to have something in this driver that understands change streams. This is one of the most interesting things to build in drivers, in my opinion, because how do you deal with something that you sort of listen to and it notifies? I mean, it's obvious in an asynchronous language. In JavaScript, it's like, here's a function. Call this function every time there's a new piece of information. But if you've got a synchronous language, how do you set up something that, you know, is listening for something to happen? So it's one of the things that, you know, very much is different for the different idiomatic languages. Server discovery and management. So one of the things, when you connect to MongoDB, a lot of the time you're going to connect to a replica set. And you need to keep an eye on that replica set because we need to know if a server goes down. We need to know which one's currently the primary. We need to know where to route things. I have a question. Excellent.
One thing I love about this exercise is make us think about how to break things down to smaller components. But server discovery and management, like how is that different than connection pools? You know, it's like similar, right? They're so similar together.
Great question. So connection pooling really is working at the sort of lowest level. So I want to send a message to the server. I kind of fire it down as the connection pool. It finds one of the multiple connections I have to the server and it scoots it along there. And we have multiple connections in a pool because we might have multiple threads that want to write things. We're waiting for a response coming back from one. You know, somebody did a bad unindexed search. So we have to have that pool of connections open. Server discovery and management, it does tie into connection pooling, but it's in most drivers, it's actually a separate thread that sits there and polls the cluster to say, what nodes do you have? What's up? What's down? Even the initial discovery. So when you connect to a replica set, you quite often give it all the hosts, but you don't need to. You just need to give it any one host that is up at that point in time, and it will discover the rest of the replica set. If somebody adds a host to a replica set while you're using it, then the driver will discover that. So you can be connected. You've got your connection pool up. Obviously, connection pools go to physical servers. So what's going to happen is somebody adds a new secondary to your replica set. It's going to be discovered by the server discovery and management. It's going to open a connection pool to that server, and then it's going to start firing off operations to that when appropriate. Make sense?
Yeah,
so higher level.
That's just a struggle for me personally, is how to break down your software, right? How do you break it down into little components? And when you have a component that's too big to break it down, right? Like I honestly, if I was building from scratch, I may have put that together, but maybe that's a bad approach. Maybe splitting it out. I'm sorry. Maybe splitting it out the way you're talking about is better. But these are the problems that we have as computer engineers, right? How do we break down our problems? How do we solve them? How do we microservice this? And it's like a microservice within this driver, right? It's really what it is. And so it's interesting to think about this stuff. So thank you.
Yep. I mean, connection pooling. I mean, you could get away technically without a connection pool, but you definitely need something that's monitoring the state of your cluster. You know, at the very least, it needs to know what the primary is. And if the primary changes, it needs to know this is where we send things. Session and transaction management. So there is the concept of a session in MongoDB. There's a concept of operations within a session where you guarantee the order things happen. We have ACID transactions. I need to be able to begin a transaction, do things, and commit. And the driver itself needs to keep track of certain IDs. You know, when you run an operation through the driver, what transaction is that operation associated with? What session is that operation associated with? The driver actually keeps track of the concept of the the atomic time, the Lamport clock time on the server as well. So, you know, it knows when things happen relative to other things. Server selection. Yeah, so this is another one of these, hey, what does that mean? So this is why I said, you know, I'll explain something and then you can decide whether you wrote that down or not. So if I say, hey, do this query on the primary, that's easy. You know, it knows what the primary is. But if I say, hey, do this on the nearest server, or I say, do this on a secondary, then the driver has to have some smarts to know where it should send it. You know, the nearest server is not necessarily the one with the shortest ping time. It's the shortest ping time or anything within 10% of that. So server selection is about when I do an operation, given that this is a distributed cluster of multiple servers, you know, particularly in the respect to a replica set, which server should I send it to? Handling retryable reads and retryable writes. So, you know, MongoDB, the driver gives you that guarantee. It tries to do a write. Oh, I'll finish my sentence and then we get it. So it tries to do a write. It also gives us time to get a microphone to you. And then it fails because the primary is down and there's an election going on. MongoDB will hold on to that write until a new primary is elected, and then it will send it there instead. So handling this idea of, you know, I do an operation, but there's a transient failure because an election is happening, but I'll still make sure it happens for you definitely anyway. Okay, your question.
Regarding the previous slide, how does server selection differ from server discovery and management? Like, is there an overlap there? Because just by the terminology, it sounds like there would be.
Okay, so I guess there is a bit of an overlap here. And just to be clear, all of the things I'm going through are like things we have separate specs for. So server discovery and management is about continually monitoring the cluster to know what servers exist and what their roles are. Server selection is about choosing which server to send any given request to. So when somebody does something like a find with a read preference of nearest, which server should I send that to? If they do a preference of secondary, for example, I'm going to have, you know, at least 2 secondaries most of the time. It doesn't always send it to the same one. It kind of divvies it up and round robins it between them when everything's working. There's also various rules in there about network latency. Like if one of my secondaries is a very long way away, we'll not send things to that when you say secondary. So there's a whole bunch of logic around for any given operation, which node in my cluster should that go to? And that's not taking into account sharding, where I just send it to the MongoS and let it deal with that whole problem.
John, you have 2 questions. Is this a good point, or can we wait till after the talk?
We have more questions. I can answer questions. We have 6 minutes, 59 seconds remaining and 2 more slides. So question away.
All right. I'll hold it.
The session management, like what we cover, say that doesn't cover the session selection or server selection, because sticky session or round robin that you said, so that should be the part of session management or not?
I think so if you are, sessions in the MongoDB sense really only apply to working with the primary. So these are not, we're not talking HTTP sessions here. You know, we're talking MongoDB transactional ordering sessions. So if you're doing something on a session, it's nearly always write operation, or it's an operation you need to have a kind of guarantee read your own rights, so it's always going to be against the primary. So session management is, you know, about keeping track of the session handle, and if you've opened multiple sessions, you know, because you want certain transactional guarantees within that, it's those. So server selection generally is only going to apply to reads, and reads from secondaries, as far as I know, are not going to be part of a session. But it's not a session in the sense of like an HTTP session or a cookie session. It's a much lower level concept than that. That makes sense?
Yep.
Cool. Good question, though. Nelly didn't know she was going to be running around all day.
On the server selection, is load balancing covered or is it a separate?
So load balancing, it's an interesting, yes, it basically is. I mean, MongoDB doesn't do load balancing other than if you have a bunch of eligible servers for any particular read preference, then it will kind of randomly select between those. It has no concept of how busy a server is. But what it will do is if, for example, all 3 of the nodes in our replica set are approximately the same distance away from me, and I say, do this query on a secondary, it will randomly select between the secondaries to make sure that that happens. But there's no kind of real load balancing going on. Obviously, you're all aware that you should never read from secondaries anyway. That's why we have sharded clusters. That was, yeah, slightly joking. Okay, do I have anything else? Oh, yeah, actually, this is my last one. I put this to the drivers team because these slides were written a few years ago. And he said, no, the other thing you need to write is a complete test framework for your driver to make sure it completely fits to all of the specifications. And I said, okay, I'll add that in. But I bet nobody put that. Anybody put test framework? No. That's all right. It took till last year for our driver engineers to agree on one as well. Okay, so that's my complete list. Okay, so do you have anything on your lists for our remaining few minutes that I didn't mention but you don't think falls into any of those categories? Gentleman at the back. Authorization. Okay, interesting question. Does the driver do any authorization? In fact, it doesn't. All the authorization is handled by the server side of things. So you need to authenticate, and for authentication, beyond the very trivial, there's work that needs to be done, like integrating with Kerberos or dealing with a SCRAM challenge response in the driver. But all of the authorization is then done by the server. It knows who you are because you've authenticated, and it deals with that. Anyone got anything else? Sorry, who was? I don't know who to look at. Hear that?
So how you handle the caching or the query optimizer, like whatever the queries are frequently running?
Okay, so caching, MongoDB does not ever cache your query results. Caching query results might mean we get results that are old. So there's no query result caching. Cursors are something you can only read from once. You can't reverse on a cursor, so you can't go back on that. There is, of course, caching of the records themselves in the database cache, so something that we've read recently. So you said caching, and what was the other thing? Query optimization. Again, the driver doesn't do any query optimization. The driver is the client-side piece of code that sends your request to the server. The server is then going to deal with all of the query optimization for you, but it's a server feature rather than a client one. Does it? It doesn't validate. Well, so queries are not sent as text. Remember, everything over the wire in MongoDB is sent as BSON. It's sent as an object. So one, we do a check for bad BSON over the wire, but that's a server-side check. But yeah, if you send a completely invalid query, like you send something with an operator that doesn't exist, it's going to be the server that's going to complain about that. Well, you're writing the driver in your language, so that's that side of it. Okay, we are very much running out of time. So I want to see, you've all ticked off things, and on your honor to have got them right. The largest number of things somebody had written on their piece of paper was 11. Did anybody get 11 things correct? 10? 9? 8? 8. Okay, so we had 8 of those things. 7. Okay, I was going to offer you a job, but if you can't count from anybody got more than 7? Okay, a round of applause for this team here. I will try and find you some funky swag for that. Thank you very much. You've been an excellent audience, but I have 6, 5, 4, 3, 2, 1, and we're done. Thank you very much, and I hope you enjoyed the exercise.
Thank you, John.